Right. Mock exams aren't far away, so let's try at least one question per day. Okay, so we have a model, exponential model, and it shows the surface area covered by the weed in 8 meters squared. So first question, we need to show this, state the surface area of the pond by the weed at start the investigation. Whenever it says start, we know that the time is going to be 0. Okay, so e to 0.3 times 0. Okay, and all that's going to give us is 0.2 meters squared. Okay, and you can check that with your calculator. So 0.2 e times 0.3 to 0. It's going to give you 0.2 meters squared. And I'm sure it's important you keep the units there. So that's question A. Question B. Let's have a look. Might make these a bit smaller. Right, question B, let's have a look. Find the rate of increase, okay? I'm going to highlight this keyword, rate of increase, of the surface area covered by the weed in meters squared per day exactly 5 days after. So when it comes to rate of increase, okay, if we want to find the rate, we must differentiate, okay? And we're going to take the differential, so it's going to be dA with respect to time, okay? Because that's how the surface area is going to change over time. That's how we're going to figure out the rate of increase of the model, okay, of the area. So 0.2, how we do it is this coefficient right here, this 0.3 is going to be multiplied by the coefficient in front of E. So it's going to become 0.06 E and then 0.3 T. Okay, that will remain the same. Now they want dA dt exactly 5 days after. So when T equals 5, we're going to put 0.06 E times 0.3 times 5. And whatever result you get into your calculator, I would just put it, round it appropriately, okay? So let's see, 0.06, shift 0.3 times 5, and that gives me 0.2689 dot dot dot, and I'm just going to round it up to 0.27 to 3SF, or 2dp, okay? I think that's acceptable. 2dp is acceptable. They haven't given us a unit of accuracy, so I would say, so long as you show them this and then you show them how you rounded it, that's okay. Right, given that the surface area, find to the nearest hour the time taken. Now, I think there will be two ways to do this, and I'll love to know people's opinion on this actually. So, 100 is going to be equal to the 0.2 e to the 0.3 t. Okay, then we're going to do 100 divided by 0.2, which gives us 500 equals e to the 0.3 t. Then we're going to take the natural log, so 500 ln 500 ln e to the 0.3 t. Why are we doing that? Well, to get rid of the exponential, we must take the inverse, and the inverse of the exponential is the natural log. Okay, so natural log of ln 500 equals 0.3 t. So therefore, it goes to say that t is equal to ln 500 over 0.3. Okay, and I hope that makes sense. Now we're going to put that into our calculator, ln 500 divided by 0.3, and this gives me 20.71 days. Now here's the problem, and here's where I think there might be a problem. Okay, it says find to the nearest hour the time taken. Now, what's to stop someone from doing 20.71536 times 24 and converting it completely to hours, which would be 497.16 hours, and then 497.17, or 497 hours to 3SF. See, this is where I'm not too sure, okay? But what we might do is keep it in days and hours, and that could be 20.71536, and then times that 0.71536, 0.71536 by 24, and that gives you 20 days and 17 hours. But see, the problem is here. If someone said 497 hours, they're not wrong because 20 times 24 is 480, and 480 at 17 is 497. But I don't know if this would get you the credit, and I don't know if I agree with that because they haven't told us really what they want it in. Because if they say for the nearest hour, well, why would you do a partial conversion into days and hours? But I've just given both answers just to show you. Right. Okay, question D. Let's see if we can squeeze it in here. See if we can squeeze it in here. The pond is observed for one more month, and by the end of the month, 90% of the area was covered. Right, so we can just say, let's think about it, right? What did they ask us? They asked us, how long would it take to be fully covered by the weed? Okay, and it took 20 days, or 20.71 days. And they're saying but 19% is not covered by a full month. So the model has to be inaccurate. Model is not accurate. Why is it not accurate? Well, the reason why it's not accurate is because nine in our model it took 20 days to be fully covered. Pool was fully covered in 100%, or you could just say to be fully covered. Okay, and their model, or the actual and the pond, took 30 or 28 to 30 days to be 90% covered. So that's why I'd say the model is not accurate. Okay, the model is not accurate because in our model it took 20 days to be fully covered, and the pond took 28 to 30 days to be covered in reality, or And although that explanation wasn't the best, okay, you get the point. The model isn't accurate because our model says it should be fully covered in 20 days, and in reality, it took a whole month, and it's not even fully covered yet. So our model is over predicting um, the growth of the weed. It's over predicting, and you could even say that um, our model over predicts growth. It is only just one mark, but just make sure you're thorough. Okay. So yeah, apart from question C, or part C, where I had a little bit of a debate on whether it's this answer or that one, I hope you've enjoyed the journey so far. So we finished the specimen paper for pure. It's been a good journey. And now we're going to move on to statistics and mechanics. So I'll see you there tomorrow. Peace.